Well, greetings, mathletes, and welcome back. Today we're going to be talking about one-sided limits. Now, we haven't given any consideration at all to one side of a limit or another side of a limit up until this point. We're just kind of saying limit overall. But we're going to make the connection today between a one-sided limit and our general limit. And really, it's more of a we're getting a feel for these one-sided limits and what they actually mean. And so because of that, we're going to be looking at most of these limits from pictures. So there won't be a lot of computation today. It's mostly just understanding the concepts. Okay, so here's our function for our first example. This is our function. We'll just call it f. So this is our function. Whoa, let's make that smaller. There we go. Let's try that one more time. In any case, this is f of x. Okay, and what we're going to do is we're going to take the limits of f of x from different sides and just kind of look through things. Now, the idea of, a right and a left-handed limit is basically if you have a graph and there's some point C here, right? If you want to take the limit at C, from the right-hand side, basically you don't consider the left-hand side and you look at just what the right-hand side is coming up to. If you want to take a left-handed limit, you come in from this side. I mean, that's the basic idea. Now there's some notation for it. Okay, if you're going to be approaching something from the right-handed side, right? So if I wanted the limit of f of x as x approaches c, and I want to indicate that I'm approaching c from the right-hand side, what I do is I write a little plus. That's supposed to be a plus. Let's try it again. I write a little plus next to the c. Notice that's not in front of the c because that would change the sign. It's just telling you that you're coming in from the positive side, so that's on the right. I should probably be a little careful with how I'm pointing just because the the camera is reversed so I can see what I'm doing. So this is a right-handed limit. And if you want a left-handed limit, it's a good thing I'm a mathematician because I can't even abbreviate limit right. If I want to come in from the left-hand side, I just put a minus on it. So that means I'm just considering the values that are less than c, right? So this is a left-handed limit. Okay, so that's the notation. Let's see how this plays out now. So let's get these definitions off here and actually find some values here. So the first place I'm going to start with, and this is actually more or less how your homework is formatted too. So the first thing they'll ask you is for a function value. What is f of -3? Okay, so that's just asking what's the value of the function at -3. So we come over here to -3 and we look. Right there, okay, -3 is at 2. Okay, so we can see that. No problem. Then we take the right-handed limit. So this time we're approaching -3 from the positive side, right? So this is the limit as x approaches -3 from the positive side of f of x. So that means I'm not looking at anything on this side, right? This stuff is out for the moment. So I'm gonna get that off there because it's going to be in my way ultimately. What I want to do is just look at what value the function is approaching if I just come in from the right-hand side. Now, if I look at this, I can see the y value it's approaching is 2. Right? So we're doing this entirely graphically. Okay, no problem. I just look at the one side, and that's my answer. Then I want to look at the limit from the other side. So it's approaching -3 from the negative side of f of x. And if I look at that from this side, what's happening is it's approaching the exact same value. Okay, so the last question you're going to be asked is just the limit as x approaches -3 of f of x. Now, here's how this works. As long as these two values here, the right-handed limit and the left-handed limit, if those two values match, right? So in this case, they're both 2's. That means the limit exists, and it's the same as both the right and left-handed limit. It turns out if the right-handed and left-handed limits don't equal each other, then the overall limit does not exist. Okay, so let me write that down here as an actual statement here. If the limit as x approaches c from the right of f of x is not equal to the limit as x approaches c from the left of f of x, then, oh, that's not a limit. Then the limit as x approaches c, notice this doesn't specify side of f of x, does not exist, right? So if the limit exists, it has to be the same limit from both sides. That's actually how these things are connected here. And this is why we're looking at right and left-handed limits. We don't have a lot of application directly for them right now, other than just looking at these things and being able to tell if the overall limit exists. But they do become important at different times throughout the calculus series. So this is definitely something you need to at least understand and have a basic concept of. Okay, so we have that now. Let's go ahead and delete a bunch of this stuff. I wanted to get that off of there. Yeah, close enough. Okay. So now the next point of interest that I'm going to look at is let's see here. How about f of 2? So we're going to look at x equals 2 here, and we're going to look at limits and function values around that. So first of all, f of 2, if I look at it, the actual function value is 0. Okay? Right, and keep in mind we're in here, right? I'm just drawing that little dashed line so we can see what we're looking at. Okay, so now let's check out the other two limits. Let's look at the limit as x approaches 2 from the positive side of f of x, and the limit as x approaches 2 from the negative side of f of x. Okay, so if I look at this, let's see here. If I come into 2 from the positive side, it looks like I'm approaching a function value of 1. So the limit there, if I approach from the positive side, is 1. If I approach from the negative side over here, the limit approaches the function value. So that's a 0. So when you're asked about the overall limit, the limit as x approaches 2 of f of x, these two values here don't match now. This one and this one are not the same value. They're not equal. And so what that means is that this limit does not exist. Now in the next chapter, or not next chapter, the next section that we're going to cover, this becomes important too. Because if it turns out that the function value is equal to the limit, that's how we tell if something is continuous or not. So that ends up being a very important discussion, whether a function is actually continuous or whether it's discontinuous at a particular point. Okay. So again, notice we're really just looking at the picture and seeing what the picture tells us. So this is all about just being able to interpret data. That's really what this is more about than anything else. Okay, so let's go ahead and clear this off. And maybe I can be so careful as to erase. Maybe I can't. I don't know. We're going to try. Ooh, that didn't work. That's fine. Well, we know where the rest of the function is. Let me just erase this here. All right. So here's what I want to do. Let's look at one more here. Let's say we're going to be looking at 5. right? So we're going to be checking this out when x is equal to 5. So I want you to find f of 5. Wait, that's a 6. I can't read. So I want you to find f of 6. Then once you find f of 6, let's look at the limit of f of x as x approaches 6 from the positive side, the limit as x approaches 6 from the negative side, and the overall limit. There we go. Okay, so I want you to find these 4 things. So go ahead and pause here, and then we'll take a look at it together after you're done. Okay, so I'm assuming you've already worked on it. So let's take a look here. So to start out with, the function value at 6. Well, that's an open dot, so the function value is up here. So the function value is at 2, as far as that goes. Then we want to approach 6 from the positive side. So if I approach from the positive side, moving up this way, the function value is going to 2. Okay, now if I approach 6 from the negative side, from this side, I can see the function value is not heading up to 2, it's staying at 1. Okay, now these 2 values do not match. If these 2 values don't match, then the overall limit doesn't exist. So this is, I shouldn't say it's equal to, it just simply doesn't exist. But that's pretty standard. D and E generally means does not exist in mathematics. Okay, so normally I would ask if there's any questions or things like that at this point, but well, it's a video. What am I going to listen to? Okay, so that's the main idea, right? It's really just a matter of getting a look at what the function does and then deciding where it heads. Okay, now I do want to talk about one particular function, which it's an interesting function. I like it. And it's f of x is equal to the absolute value of x over x. Now, part of this is just knowing what the graph of this thing looks like. So let's think about what happens here. If x is greater than 0, right, then the absolute value of x is just the absolute value of x, right? And if x is greater than 0, that means it's already positive. Then f of x is going to be is the same thing as x divided by x, right? That's when it's positive. X divided by x is 1. So that means any positive number you plug into this function, you get a value of 1 out. If I look at the other side, if x is less than 0, well, that means if it's less than 0, that means x is going to be its opposite. The absolute value of x is going to be its opposite, right? Because I'm putting in a negative, so I have to get out a positive, which means I'm going to change the sign. So that means if x is less than 0, then this is equal to negative x over x, which is negative 1, right? And at 0, well, let's look at what we actually get. F of 0 would be the absolute value of 0 divided by 0, and this is indeterminate. Right? And I say indeterminate rather than undefined. Right? Division by 0 is undefined, but if you're dividing 0 by 0, that's actually indeterminate. And that's actually part of the reason that we can remove those discontinuities when we're taking limits and cancel factors out and stuff. That's when we have an indeterminate form. So it's going to be important to know the difference between undefined and indeterminate. Okay, but what this ends up boiling down to is if I draw myself a little axis here, and this is 1, and this is negative 1, there's a hole here, and this function looks like that, and then there's a hole here, right? That's supposed to be on the axis, and it goes that direction. So you have this break in the function, right? And so clearly from here, the right and left-handed limits are going to be different. Um, if I take the limit of this as I come in from the right-hand side, the limit is 1. If I come in from the left-hand side, the limit is -1. And if I evaluate the function f of 0, right, it's undefined, right? There's no function value there, or indeterminate. But the function value has not been defined. So that's one of those things that you do have to pay attention to. And so this is really the last thing I wanted to mention. It's just because that's a little bit new, so you should know what the function looks like and what it does. Because you may very well be asked to take a limit of something having to do with this function. So, fortunately, where'd it go? There it is. Okay, so fortunately, we didn't have a lot of stuff to look at today, and this is the second half of the lecture I gave you guys on Tuesday. So, in any case, this was the lighter part of the chapter, and we're going to be able to finish this a little bit early today. And so, until next time, keep your pencils and your wits sharp.